In this session, we are going to learn design of Cotter joint. Cotter is a flat wedge shaped piece of rectangular cross section and its width is tapered at one side. The Cotter joint is a temporary fastening element and it is used to connect rigidity to two coaxial rods. In this topic, we are going to learn design of Cotter joint. As shown in the slide, the picture is of Cotter joint. What is Cotter joint? Where it is used? Cotter joint is used in bicycle to connect paddle to sprocket wheel. Cotter joint is used to connect piston rod and its auxiliary parts. Cotter joints are popular to connect strap end connecting rod. Cotter joint has three parts: spigot, cotter and socket. Spigot and socket is connected by means of rectangular strip known as cotter. Let us see different parameters of cotter as shown in the figure. P is the load carried by the rods. D, that is diameter of rod. D1, outside diameter of socket. D2, diameter of spigot, or we can call that inside diameter of socket. D3, that is outside diameter of spigot collar. T1, it's a thickness of spigot collar. D4, diameter of socket collar. C, B are the special terms related to collar and cotter. T, that is thickness of cotter. L, length of cotter. The material used for socket, cotter and spigot are mentioned over there, and the permissible tensile stress of each material have given over there. Let us start design process. As we know, rods are in tension due to tensile load. The resisting area is pi by 4 d square. So we can find out the diameter of rod d with the help of this equation. Next, let us see the design of spigot. A weakest section of the spigot is shown in the figure. So, we can calculate the diameter of spigot, that is D2, with the help of this equation. In actual practice, thickness of cotter T is usually taken as D2 by 4. Now, we will check the failure of cotter due to crushing. We know that the area that resists crushing of the rod, that is D2 into T. So, we can check the crushing stress induced in cotter socket. Now, we have to check the socket for tension failure. The weakest portion is shown in the figure. First, calculate the resisting area of the socket across slot. Then check the tearing strength across slot. From this equation, outside diameter of socket may be determined. Now to check failure of Cotter due to shear. As shown in the figure, it is clearly mentioned that Cotter is in double shear. Therefore, we can determine the width of Cotter with the help of this equation. Next step is to check the crushing failure of socket collar. As shown in the figure, where the weakest area of the socket collar is shown, through which we can easily find out the resisting area of socket collar, and thus we can determine the socket collar diameter, that is D4. Since socket end is in double shear, therefore we have to consider double shear for obtaining thickness of socket collar, which is C. To calculate distance of slot from end of rod, which is denoted by A, can be obtained by showing the resisting area of rod end. As we know, rod end is in double shear. Therefore, we can easily find out the distance of slot from end of rod, that is A. Consider the failure of spigot collar in crushing as shown in the figure. The figure shows the weakest section of spigot collar due to crushing. This resisting area resists the crushing failure of the cotter. Thus, the diameter of spigot collar D3 can be obtained with the help of this equation. Weakest section of spigot collar is shown in the figure. So, we can calculate the thickness of spigot collar T with the help of this equation. In all of the above calculation, we have assumed that load is uniform and uniformly distributed over the various cross section. But in actual practice, this does not happen, and cotter is subjected to bending. So, while designing cotter, bending failure should be considered or should take into account as shown in the figure. The bending stress, that is sigma b, is equal to m by z, where m is the bending moment and z is the section modulus, which we have to consider while designing cotter. For simplicity and uniformity, standardization principle should be adopted in design. So some of the assumption of different parameters made easy and simple the design procedure. Therefore, there are some tabular parameters shown. These assumptions are to be considered while designing cotter joint.